This optimization problem is about the maximum area of a rectangle. So given that the perimeter of a rectangle is equals to 80, so I have a rectangle, I define the length and width. The length is x, the width is y, so 80 means the 2x plus y plus y, that is equals to 80. The question is what x should be and what y should be such that the area is maximized. So when you deal with optimization problem, you have to define the variable first. So we just did. The width is y, the length is x, and then the next step is to determine the secondary function and primary function. So what is primary? The primary is what the question is asking. The question is asking you to maximize the area. So area is your primary function. So the area of a rectangle is x times y. So this is one function in two independent variables, x and y. We cannot just take the derivative like this. We have to rewrite y in terms of x or x in terms of y. So let's see what can we do for the secondary. So for the secondary function, that refers to what is given. They gave you that the perimeter is equals to 80. So the perimeter is 2x plus 2y equals to 80. So 2x plus 2y equals to 80. And let's try to write y in terms of x. So the way I do it is I factor out the x. So that is equals to 80, and then I divide 2 on both sides. So x plus y is equals to 40, and then y is equals to 40 minus x, and then I will substitute the secondary to primary. So, and after the substitution is done, the area function is in terms of one independent variable, which is x. And then usually for the secondary function, you have to draw a domain for x. So for x, I will say the minimum x is 0 and then the maximum x is 40, right? So the smallest x pass, because they are talking about the length. Length cannot be negative. Length can be 0, but length cannot be negative. So the minimum is 0, the maximum is 40. All right, and then you substitute the secondary to a primary, and then you write the primary in terms of one independent variable. So a is equals to x times y, which is 40 minus x. And then now, let's don't call this a, let's call this a of x. The area is in terms of one variable. And then to find the maximum area, so you are trying to maximize, you are trying to find the maximum value of the area function, right? So for the maximum, still remember your local minimum. How do you local minimum and local maximum? How do you find the maximum? So to find the maximum, you need to analyze the slope. So in order to get a maximum, the slope has to be going up and then horizontal and then going down. So at the point where the slope is horizontal, we have a maximum. So we need the slope. Therefore, we need to take the derivative. So we take the derivative of the area function. The derivative of the optimization problem is usually very easy. Now, we just did the hardest part. The hardest part is figuring out the primary and the secondary. Also, plug in the secondary to the primary. That's the hardest part. Other than that, you are done. And then if the problem did not give you a graph, then the hardest part will be sketching the graph, because for the three-dimensional object, the graph is pretty complicated. Okay, the graph and the functions can be pretty complicated. So if the problem didn't give you a graph, the hardest part would be sketching the graph and label what you already know and what is unknown. All right. So this a prime of x, we should distribute first, right? Okay, let's distribute 40x minus x squared. That only cost me one extra line. So a prime of x, that is equals to 40 minus 2x. And then to find the point where there is a horizontal tangent, you have to set the slope equals to 0. And then you solve for x. So you have 40 equals to 2x. And then therefore x is equals to 20. And this is a critical number or value. Critical number or value. And then the next step is you have to prove that when x is equals to 20, the area is maximized. If you don't want to go to the sign chart, the easiest way is you want to test x equals to 20, and then the two endpoints, x the smallest and the biggest. Okay, I can tell you right now that x equals to 0 and x equals to 40 makes no sense, because for the perimeter, when x is equals to 0, you have low length. When x is equals to 40, you have low width. So basically testing the 0 and the 40 makes no sense. But let's do it anyway. When x is equals to 0, you have 0 and then 40 minus 0, x equals to 20, then you have 20, 40 minus 20, and then x equals to 40, you have a 40, and then 40 minus 40. So the first two lines gives you a 0, right? So this gives you a 0, this gives you a 0, and then the second line is 20 by 20, that gives you a 400, right? Did they use any unit? No. Okay, then I will just leave that as 400. If the problem you see on your homework use any unit, like let's say centimeter, if they use centimeter, then this will be square centimeters if they mention the unit. All right, so since I didn't mention the unit, I don't want to add anything to it, just leave it as 400. So now you can see that 400 is the maximum area. Again, 0 means you have low length, 40 means you have no width. So how about using the sign chart? So using the sign chart, you have one critical number, right? So one critical number, and then you drop that down. Let's use a different color to give you a like contrast. So 0, 20, and then 40, we block everything off. So this is from 0 to 20, and then this is from 20 to 40. You pick something easy to test, x equals to 1, x equals to 21, and then you plug it into the a prime because you are testing the slope. So a prime of 1, that is 40 minus 2 times 1. So this is positive, and then the double prime, a prime of 21. So that is 40 minus 2 times 21, that is definitely negative. So we have a positive slope, we have a negative slope. So going up, horizontal going down, that proves when x is equals to 20, the area is maximized. All right. Okay, let's come up with the conclusion. We did all the work, so what is your conclusion? Tell me. Give me a conclusion. So the conclusion is, we have a rectangle, so the x has to be equals to 20. So x equals to 20. So x is equals to 20, then what is the area? I know that x equals to 20. How about y? So when x is equals to 20, so when x is equals to 20, so we have 20 times 20 plus 2y equals to 80. Oh, 2 times 20, huh? I wrote 20 times 20. So this is 40 plus 2y equals to 80, then y has to be equals to 20. So x, this will be 20 by 20. So if the area is maximized, then x has to be 20, y has to be 20. So I think you can think about this is as this. You are trying to construct a four-side area slash square. So for four-side perimeter, not four-sided rectangle slash square. Okay, so the materials you have, like let's say we are talking about fence. You have 80 feet of fence. You want to build a four-sided rectangle or square. What the length and the width should be such that the area is maximized. So here is how you want to construct your four-sided object. I will just build a rectangle, and then the side, and then each side is 20. So let's draw a rectangle. In order to maximize the area, so this will be just 20 by 20, so that the area is maximized, is 400 square feet, square centimeter, depending on the unit mentioned in the problem. Alright, so that is the end of this problem and this video. If you like the way I explain this, give me a like, share, and subscribe, and I will see you all in the next optimization problem. Signing out.